And here we are again. Before we get on the screen, there are certain questions you might have in your mind. You might be wondering, Rakesh, there are already so many languages out there like Rust, Solidity, JavaScript, you name it. Do you really need another one? That exact the question I had when I ever first looked at Move. So, what's special about it? What exactly is Move? Let me convince you to learn Move. Move is specifically designed for secure and flexible smart contract. Unlike general purpose languages, it focuses on safety in the blockchain world. It's resource oriented, which is a big deal in Move. As in, like, tokens aren't just number in database; they are treated as first class resources. It's make it nearly impossible to accidentally duplicate or lose them. And on Sui blockchain, Move is a language that control on-chain object. That means it's not only about writing smart contract, but also about managing data efficiently and securely. In the previous video, we already set up our environment. We will see some syntax level stuff like primitive data type and lot more in Move. Now, what are we waiting for? Let's move ahead on the screen. Let's start with the ownership model. First thing, Move follows an ownership model very similar to Rust, and if you're familiar with the Rust, this will be very easier for you. This means when you assign a value to a variable, that variable owns the value, and once the ownership is transferred, the older variable can no longer use it. Let me give you an example which says, suppose this is your memory. This is a stack memory, and you define a variable which is a and point to a value which is 10. And on the code, you have given that let a equal to 10, and at the same time you said let b equal to a, which means that another variable b will be declared and the pointer will point to the same value, and the ownership moves to b and the pointer of a will be deleted. A cannot be used here anymore. This ensures a memory safety and avoid common bugs like double spending or accidentally freed memory. Now let's jump into the data type. What are the data types? We will see the top 4 data types which are commonly used everywhere in the Move language. Let's start with the first one, which is Boolean, which is true or false, 0 or 1. And the another one would be U8 or U32 or U64. So what U stand for? Unsigned integers, where 8, 32, 64, 128, these are the bigs. For example, U8 can store values from 0 to 255, while U68 can hold much larger numbers. The third one would be address, represent an account address on chain. The fourth one would be vector. Then, and what is vector? Vector is a dynamic array where t is the type of the element in stores. Now let's come to the syntax part. How does this in Move language actually looks like? So let's define module. So the name of our module will be Move playground : data types. So what it is? Module in Move is like a container for your code. Think of it as like a box where you put all related functions, stuff, your business logic, where every smart contract in Move is basically written inside a module. So the Move playground here, it is the address or namespace where the module lives, and the data type is simply the name of the module. Now let's define a function which is for say demo. Let's make it a public. The visibility of a function like public, private, we will see in the upcoming videos. For now, it is more important to understand the data types. Let's write the first variable, which is Boolean. Let is active. Yes, my user is active, so I will define true. Now let's write a U8 integer. let's small number, which is U8 and equal to, let's say, 200. Now let's write big number. Let big number. For now, let's give it a U64. My big number would be N0. Now let's write the address. Let account address equal to, let's say, @0x1. This is the account standard library address. Now let's write numbers, vectors, vector which is of type U8. Now let's write a vector and square bracket and 1, 2, 3, 4 and elements. So these are the data types which we have seen, like boolean, unsigned integers, address, vectors. Most of the time we'll be using this, like stored booleans, small number, big number, hold and account address, and unsigned integers. Now let's understand one of the key component of Move language, which is mutability. By default, all the variable in Move are immutable. Once you assign them, you cannot change them. But if you want to modify a variable, you need to declare it with mute. Let's say I have defined x, which is U64 equal to 10. So now, can I change x equal to x plus 5? Absolutely no. And at the same time, I have defined y also, which is U64 equal to 20 with a mute word. Now, when I do this y equal to y plus 5, now this will not throw any error, right? So x is immutable. If you try to resign it, Move will throw an error. You can see here. Yeah, you will find an error where y is mutable because we declare it with mute. That's why y equal to y plus 5 works. Also, I will give you all the resources in the Git repo, like official Move book, link, and all of the stuff I've shown you. Now that we have seen the variable and data type in Move, it's time to understand how a Move project is structured. Whenever you create a new Move project, you will see a few important files and folders. Let's break it down step by step. Let's start with the Move.toml. So this is a file. Think of it as a configuration file for your Move project. It contains details like your project name, dependencies, and the published address. If you're coming from other ecosystem, it's similar to package.js in Node.js or cargo.toml in Rust. The next folder is sources. This is where your main smart contract code lives. Every .move file inside sources contain Move module. Typically, each module is defined in its own file. So whenever you're coding your actual logic like token, NFT, or your custom-driven contract, it all goes inside the sources folder. The last folder is test. This is where you write unit test for your smart contract. Test file usually have suffix underscore test, so they're easy to identify. This way you can check if your contract behaves as expected, deploying with on-chain. Let me give you a quick recap what we have done till now. Ownership model keeps data safe. Data type defines what kind of values a variable can store. Mutability decides whether your variable should be able to change or not. And at the end, we have seen the folder structure. In the next part of the video, we will build on this by looking at functions and control flow in Move. And yeah, see you in the next part.